The last thing we need to think about in lesson 5.5 is sketching a graph given information. So here's my function, log base 4 of 16x. So the first thing that I would do in this case is separate this up. So my plan here is to get just a log of something, or like try to simplify it down with either like a plus something or a minus something or multiplying by something, because then I could shift that graph. And that's easier to graph that way. So I'm going to start out with this. I'm going to separate it up because this is multiplication. So this is really the same thing as log base 4 of 16 plus log base 4 of x. So then I can rewrite this. So if I'm in a base 4, if I can get this base to be a 4 with an exponent, then I can simplify this. So 16 is the same thing as 4 squared. So I'm going to write this as log base 4 of 4 squared plus log base 4 of x. So this situation right here is just 2. So use your rules again. This is just that exponent of 2. Plus this log base 4 of x I can't really do anything with, but I now know that I could graph this, and then because they're just adding 2 to it, I could shift it up 2. So that's what this tells me right here, shift up 2. So I'm going to graph log base 4 of x, and then I'm going to shift it up 2. Now, let's think about what this looks like. So log base 4 of x, let's say I've got that equation, y equals log base 4 of x. Well, what that actually means, use your rules, because I need it in just like an xy equation, right? So this tells me that I have a base of 4 to the y power equals x. And I'm actually going to put the equals x on this side. So that's x equals that stuff, right? So this is what I'm graphing. And then I'm going to shift it up 2. Okay, so I'm going to make really 2 xy tables here because I'm going to add 2 to it over here. All right, so if I start out with this one, I'm just going to plug in some numbers for y. So -2, -1, 0, 1, and 2. Remember, this is an inverse, so that's why I'm plugging things in for y. It's an inverse of an exponential. So I'm going to plug things in for y and get my x values. So if I plug in a -2 for y, that's 4 to the -2nd, or 1 over 4 squared, which would be 1 over 16. If I plug in a -1, that would be 1 over 4. If I plug in a 0, anything to the 0 power is 1. If I plug in a 1, I get 4. If I plug in a 2, I get 16. So 4 to the first power is 4. 4 to the second power is 16. Okay, so there's that. But then if I'm going to shift it up by 2, that means my y value is going to increase by 2. So for this one over here, I'm just going to add 2 to all of these y values. So these are going to stay the same, 1/16, 1/4, 1, 4, and 16. But these are now going to be, this one's going to be 0. This one's going to be 1. This one's going to be 2. This one's going to be 3. This one's going to be 4. And then I'm going to graph this one, because this is the one that has been shifted, which is my actual equation. Okay, so I end up with, so if I go over to 1/16 of the way over, I have a point on the x-axis at 0. And then I've got 1/4 of the way over at 1. I've got at 1, 2, I've got a point. At 4, 3, I have a point. And then at 16, 4, which I can't fit that on my graph, so I'm just going to leave that one off. But that gives me an idea of what's happening here. So this is increasing like this very quickly, and this one is going this way very quickly. Okay. The second one, so same idea. I really want to get a log of something by itself and then think about the other part separately. Well, it's already kind of separate. I've got a 1/3 and I've got a log right here. So let's just think about this log. This is the same thing as, let's just write it out like this. So y equals log base 3 of x, which really means I have a base of 3, an exponent of y equals x. Again, I'm putting x on the other side. So x equals 3 to the y power. Now, if I'm going to multiply it by 1/3, what's going to happen there is if you're multiplying by something, it's either compressing or it's like expanding, right? Well, this is multiplying by a fraction. So that is going to compress it, and it's going to compress it down vertically. So I think I'm just going to call it that, compressed vertically. So that's when I'm going to multiply by 1/3. All right, so let's start with this one though, again. So if I've got my table, I'm going to do the same thing as I did on that last one. So I'm going to plug in -2 right here. If I plug in -2, that should give me 1/9. If I plug in -1, that's going to give me 1/3. Remember, just to move it to the denominator to get rid of the negative exponent. Anything to the 0 power is still 1. 3 to the first power is 3. 3 to the second power is 9. So there's that table. Then I'm going to multiply, if I can spell multiply, by 1/3. Okay, so times 1/3 gives me, if this is -2/1, that gives me -2/3. This one, if I take it times 1/3, would be -1/3. 0 times 1/3 is still 0. 1 times 1/3 is 1/3. 2 times 1/3 is 2/3. And these are going to stay the same. 1/9, 1/3, 1, 3, and 9. So my x values stayed the same again. And again, this is the one that I'm going to graph because I want it to be 1/3 of this log. Okay, so at 1/9, ninth of the way over, and then down 2/3 of the way. So I'm going to call that about right here. And then 1/3 of the way, and then -1/3 of the way. So 1/3 of the way would be about right here. This is a total estimation, right? Just do your best. Okay, now this is going to get a little bit easier. So 1, 0 is right here. And then 3, 1/3. So 1/3 of the way up is going to be about right there. And then 9, 2/3. Let's see if I have enough. 1, 2, 3, 4, 5, 6, 7, 8, 9. I do. And then 2/3 of the way up. So about right here. Okay, so this one looks really weird. It's because it's super compressed this direction. So it's really tight, that curve is. And then it's going to go down this direction, never actually hitting that y-axis.